All right, so this discussion of work is going to bring us to the work-energy theorem, and this is a really useful thing when we're dealing with motion of objects and forces and what have you. Now, we first need to describe kinetic energy, and kinetic energy is the energy of a moving object, and that moving object can be anything. Anything that has mass and a speed, we can define its kinetic energy. The kinetic energy we can derive by calculus. We won't do it here, but it's equal to 1/2 times the mass times the speed squared. Funny thing about kinetic energy, it was never really thought that kinetic energy should be proportional, as it is, to v squared. Instead, people thought that squared numbers were satanic, that they were a result of evil forces or that it was evil in some way. And this is kind of absurd because, you know, in agrarian societies, they use squared numbers a lot, right, to calculate areas and what have you. Instead, people thought that energy, or sort of their concept of energy, was proportional instead to the velocity. And there was a lady, Emily de Châtelet, a French lady, who devised this very simple experiment where she took a ball. She dropped the ball into clay. Right? And she knew these equations of kinematics like we have now. And so she was able to drop it and to calculate what was the velocity of the ball when it hit. So she dropped the ball, and it made a little indentation into the clay. And then she took a ball, and she dropped it from a greater height, so that when it had a velocity, it had twice the velocity that it had before. So over here it had a velocity v, and then over there it had a velocity 2v. Now, if the kinetic energy is proportional to the velocity, then it's going to have twice as much energy because it's going twice as fast. Right? And if it has twice as much energy, then it's going to go twice as deep into this clay material. Right? But what she found was not that it went twice as deep, but that when it went into the clay, that it went 4 times as deep. And so that drove sort of the nail in the coffin that kinetic energy is proportional to v squared. And then further, they were able to go on and show that kinetic energy is equal to 1/2 times the mass times the velocity squared. All right, y'all try this quick test. We're going to move on to the work-energy theorem. The work-energy theorem just says that that if you do work on an object, that changes the energy of that object. So anytime you do work on an object, you change its energy. So in short, if you do positive work on an object, you increase its energy. If you do negative work, you decrease its energy. Again, getting back to this idea that work is not a vector quantity. And so when we talk about positives and negatives, it means simply, are you adding to or are you taking away from the energy? That's the work-energy theorem. We'll use it quite a bit. We'll pause there and you go ahead and wrap up those quick test questions.